Alright, so in this problem, I have 0.01 to the power of x is equal to 2. So I want to find the value of x here. So for my solution, first start with 0.01 to the power of x is equal to 2. Now I'm going to take the log on both sides. So now I have log 0.01 to the power of x is equal to log 2. Now, if I have something in the form log a to the power of b, I can simply move this exponent b to the front. So this would equal b times log a. So in this case, I have log 0.01 to the power of x, and I can simply move x to the front. So that's going to equal x times log 0.01 is equal to log 2. Now 0.01 is the same thing as 1 over 100. So now I have x times log 1 over 100 is equal to log 2. Now if I have something in the form log a over b, this is equal to log a minus log b. So in this case, I have log 1 over 100. I can rewrite this as log x times log 1 minus log 100. This is equal to log 2. So now, log 1 simply equal to 0, and log 100 is simply equal to 2. So I have x times 0 minus 2 is equal to log 2. That's equal to approximately 0.301. Now 0 minus 2 is negative 2, so I have negative 2 times x is equal to 0.301. And now I'm going to go ahead and divide both sides by negative 2. So these two cancel out, and I'm left with x is equal to 0.301 over negative 2, which is equal to negative 0.1505. So this is my answer. Alright guys, in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 333. So to solve this, what I'm first going to do is I'm going to factor out 3 to the power of x from my left-hand side. So now I have 3 to the power of x times, now 3 to the power of x divided by 3 to the power of x, that's simply 1. So I have 1 plus, again, it's the same thing, 1 plus, final time, the same thing, and this is equal to 333. Now, if I add what's in the parentheses, I get 3. So now I have 3 to the power of x times 3 is equal to 333. So now I obviously want to isolate 3 to the power of x because this is the term that has the variable x that we're solving for. So I want to try to find a way to get rid of this 3. So to do that, I'm going to divide both sides by 3. Now, these two 3's simply cancel out, and I'll be left with 3 to the power of x is equal to 333 divided by 3, which is 111. So now I got this equation, 3 to the power of x is equal to 111. So to solve this, what I'm going to do is I'm going to take the log on both sides. So now I have log 3 to the power of x is equal to log 111. So now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So for log 3 to the power of x, I can move x to the front. So now that would lead to me having x times log 3 is equal to log 111. So now what I'm going to do is I'm going to divide both sides by log 3. So then for my left-hand side, these two log 3's simply cancel out, and I'll be left with x is equal to log 111 over log 3. So now, if I have something in the form log a over log b, this is simply equal to log base b of a. So in this case, I have log 111 over log 3, and I can write this as log base 3 of 111. So this is my answer. All right, so in this problem, I have 2 to the power of 22 minus 2 to the power of 21 is equal to 8 to the power of x. So I know at first glance, this problem looks pretty complicated. However, it's actually easier than you might think it is. So for this problem, I'm solving for the value of x. So for my solution, first start with 2 to the power of 22 minus 2 to the power of 21 is equal to 8 to the power of x. Now, it's 22 here. This is the same thing as 21 plus 1. So I'm going to rewrite this as 2 to the power of 21 plus 1 minus 2 to the power of 21 is equal to 8 to the power of x. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 21 plus 1, I can rewrite as 2 to the power of 21 times 2 to the power of 1. And I still have minus 2 to the power of 21 is equal to 8 to the power of x. And now, from here, 8, that's the same thing as 2 to the power of 3. So now I have 2 to the power of 21 times 2 to the power of 1 minus 2 to the power of 21 is equal to 2 to the power of 3 to the power of x. Now, for my left-hand side, if I factor out 2 to the power of 21, I get 2 to the power of 21 times 2 to the power of 1 minus 1. This is still equal to 2 to the power of 3 to the power of x. Now 2 to the power of 1, that's equal to 2, and 2 minus 1 is 1. So I'm left with 2 to the power of 21 times 1 is equal to 2 to the power of 3 to the power of x. Now anything times 1, it's simply itself, so 2 to the power of 21 times 1 is simply 2 to the power of 21. So I have 2 to the power of 21 times 2, is equal to 2 to the power of 3 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x, that's going to equal 2 to the power of 3 times x. So I have 2 to the power of 21 is equal to 2 to the power of 3x. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 21 is equal to 3x. So I have 21 is equal to 3x. All I have to do to solve this is simply divide both sides by 3. These two cancel out, and I'll be left with x is equal to 21 divided by 3, which is simply 7. So x equals 7 is my answer. Alright, so in this video, I'm going to solve the equation x to the power of 4 minus 16 is equal to 0. So, my only variable in this equation is x, so that's the variable I'm going to be solving for. And now for my solution. What I'm first going to do is rewrite x to the power of 4 as x to the power of 2 times 2. So now I have x to the power of 2 times 2 minus 16 is equal to 0. Now from here, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2 is equal to x to the power of 2 to the power of 2. And I have this minus 16 is equal to 0. Now from here, I'm going to rewrite 16 as 4 squared. So now I have x to the power of 2 to the power of 2 minus 4 squared is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 4. So this turns into x squared plus 4 times x squared minus 4 is equal to 0. Now I can divide this into two equations. I have x squared plus 4 is equal to 0, and x squared minus 4 is equal to 0. So for x squared plus 4 equals 0, I'm going to subtract 4 on both sides. So I get x squared is equal to negative 4. And now I'm going to take the square root on both sides. The square root of x squared is simply x. So I get x equals the square root of negative 4. Now the square root of negative 4 is the same thing as the square root of 4 times the square root of negative 1. And the square root of negative 1 is equal to I, so I get x is equal to 2i. And this is positive or negative. Now for x squared minus 4 equals 0, I'm going to simply add 4 on both sides. So I get x squared is equal to positive 4. And now if I take the square root, I get x is equal to positive or negative 2. So my four solutions are x equals 2i, x equals negative 2i, x equals 2, and x equals negative 2.